Hello, this is Jack Jackson. In this video, we're going to talk a little bit about rotations using a coordinate grid. Now, it's a little harder and more complicated using a coordinate grid for rotations than, say, for translations. Um, but there are some notable exceptions, and that's when the angle of rotation is a multiple of pi over 2 radians or a multiple of 90 degrees. Um, so, for example, here we can take the pre-image figure in blue, A, B, C, that triangle, rotate it to triangle A prime, B prime, C prime, about the center point marked right here. You can see that dot there, hopefully. And what angle did we go? Well, if you go from A to the center to A prime, I think you can see that that's a 90-degree rotation, and that would be in the positive direction. So that's a 90-degree or pi over 2 radian rotation. Okay, and so you can see, kind of see where that goes. So if you go here from A to the center is right one and up one. Okay, well to A prime that's going to be right one and down one. This has a slope of 1. This has a slope of -1, and so those are going to be perpendicular there. How about, and notice that they're by this going right one and up one, it's one diagonal, square root of 2 units, square root of 2 lengths of our little squares, um, is the distance it stays from there. How about B? Well, let's see. B goes up, let's see, 1, 2, 3 up and left 1, 2, 3, 4, 5, 6, 7. It's going to end up going, where's B prime? Well, it's down 1, 2, 3, 4, 5, 6, 7. So where this was left 7, this is down 7. And where this was up 3, this is left 3. Okay, so let's see how about C. C is left 1, 2, 3, 4, 5, 6, 7. So it's going to be down 7. 1, 2, 3, 4, 5, 6, 7. And C is down 1. So it is going to be right 1 there. Notice that that works out, so that this works out as this. Notice that vertical lines become horizontal lines. So this vertical line, vertical side of length 1, 2, 3, 4 becomes a horizontal side of length 4 down here in the image. The horizontal side length of, let's see, 1, 2, 3, 4, 5, 6 becomes a vertical side of size 1, 2, 3, 4, 5, 6. And this diagonal here is also um, the same length as that one there. In general, this line, this diagonal is going to be perpendicular. I mean, this hypotenuse here is going to be perpendicular to this one as well. Okay, here we can use my GeoGebra activity here for introducing transformations, which we've seen in an earlier video. And we can look at rotations. And I can see some rotations here, and I can use a coordinate grid. Here, show a grid. I can also uh, show some axes here if we want to put numbers with it as well. And so we can see here, this one is a 90-degree, negative 90-degree rotation from here to here. And you may experiment with this a little bit to see what happens here with the numbers and see what's happening. Let's look at what happens with 180 degrees. That one is a particularly interesting one. So one thing that's kind of interesting here is if we connect up pre-image to image points, they're going to go through the center of the rotation in this case, and notice that that gives us a 180-degree rotation. Okay, so notice what's happening here. If we do A, we're going left 9 and down 3. To get to A prime, we go right 9 and up 3. Okay, look at B, look at C. Can you determine a more general formula for that one? Okay, what if we go 90 degrees? Okay, now these are not as useful. Now what's happening here? A again is left 9 and down 3. A prime now is right 3 and down 9. Look at B. Left 6, up 5. B prime, left 5, down 6. Coordinates of B are -6, 5. B prime is -5, -6. Interesting, huh? 180 again. 180 degrees or pi radians. Coordinates of A are -9, -3. Coordinates of A prime are 9, 3. Coordinates of C are -2, 4. Coordinates of C prime are 2, -4. Can you see that we're just switching the signs on both the X and the Y here? What do we do for 90 degrees? Positive 90 degrees. Okay, let's look again. Coordinates of -9, -3. This is 3, -9. So here we switch them from 9, -9, -3 to 3, -9. So we switch them, but then we change the sign on the X one, but not the Y. Okay, what about a 270 degrees rotation or -90 degree rotation, 90 degrees clockwise? What happens here? A is at -9, -3. A prime is at -3, 9. So some interesting things there, right? That we can notice. And actually, here's a summary of that right here. So certain rotations, about the origin in particular, are easier to do with the grid and with the coordinate system. Okay. So the origin is the center of the rotation. If you rotate by 180 degrees, replace x by -x and y by -y. If you rotate by 90 degrees, replace x by y and y by -x. If you rotate by -90 degrees, replace x by y and y by +x. And there's a more general rotation if it's a different angle altogether. Okay, that's quite a bit more complicated. So see if you can apply that here. Here is our summary of rotating by pi or 180 degrees. Replace x by -x and y by -y, both in the equation and in the formula in the table, when these are matched up pre-image to image. So here we're applying it to a function, y equals x squared, parabola. Change y to -y and x to -x. Okay, that is the last one there is solved for y there. And then you can see that that's rotated 180 degrees around the origin. A half circle or pi radian rotation. Here we take y equals x cubed, replace y by -y and x by -x. That one actually simplifies back to the original. So when this is rotated, the part in the first quadrant is rotated around on top of the part that's in the third quadrant, and the part on the third quadrant is rotated back up on top of the part in the first quadrant, making that figure symmetric with respect to that rotation. We'd say that has origin symmetry. And again, there's the summary that we just went over. The next video, I'm going to use an older video where I derive the rotation about the origin by a general angle. It requires a little more trigonometry. So maybe it's a little more advanced than you would do in a high school geometry course, but you might do it in a high school trigonometry or pre-calculus course. and you can watch the video on that following this one.